Okay. One of the things that most of you, if not all of you, have at some point in your math career talked about is slope. So the slope of a line. Okay, so if that rings a bell, what is something that comes to mind? Most likely that's what pops into your head first off. Okay, so you gave me an equation, y equals mx plus b. Is there anything else that jumps to mind? Rise over run. Okay, so let's look at a few definition type things, and then we're going to talk about both of those. All right, so a slope is a ratio that compares the vertical rise, so there's that word rise, to the horizontal run. So there's your rise over run. Does anybody remember what letter, and it's in the equation you just mentioned, what letter was typically used to represent slope? M. So a slope is found by rise over run. And then when we start the unit, I'm going to point out the equation that Savannah told us. Okay, what else does the slope do? Well, it gives us an idea of the steepness of a line. So if you look at these two lines here, you can tell that this one is more steep than this line. Okay, so it helps us visualize the steepness of the line, as well as it is directional, meaning your slope can be positive or negative. How do we determine if it's a positive or a negative slope just by looking at it? You may know. Think what is occurring with the line as you go from left to right. So what is the line from left to right doing in this example? It's going up. What would you assume that that would be a positive or a negative slope? Positive. Whereas this slope going left to right is going down, which that tells me that it has a negative slope. Okay. All right. So just, whoops, wrong way. Okay, so let's start with point A, and we want to get to point C. So we're going to apply rise over run. So I'm going to start at point A, and I'm going to count how many units, 1, 2, 3, 4. So going up, we have a vertical rise of 4. Then once I get to B, I'm going to the right, which is a positive direction. 1, 2, 3, 4, 5, 6 units. And then of course we always reduce any fractions. So this would simplify to 2/3. Okay. Whereas if you'll look at from C to E, we have a triangle as well, but it's a smaller triangle. If we go up 1, 2, so my vertical rise is 2, my horizontal run is 1, 2, 3, 2/3. So we still get the same slope. You'll have the same slope regardless of where you start and end. Okay. Now, when you first learned about slope, you left your answer as slope equals 2/3. But in the functions class, we want a unit rate. Does anybody remember the significance of the unit rate? We just had something similar There's something I always want in the denominator. It's the same number in the denominator. 1. All right, so I'm going to go to my calculator and put in 2/3. Get the same thing as 0.666666. So I'm going to write 0.67. Now, if I knew what those units represented, I would label it, but I don't. Okay, now you just did something similar to this on the test, but it looked a little bit different. It was something over 1. What was that called that we just did on the test that you had to find for me? Average rate of change. Slope and average rate of change are the same thing. So, knowing that the average rate of change is the same thing as the slope. All right, let's think about, average rate of change. What was the definition of that formula? When we first learned it, I always wrote something in the numerator over something in the denominator before we did the calculations. There you go. All right, so it's the change in the function over the change in the variable, okay? So we've looked at the average rate of change in this form. We're now looking at the slope as rise over run, because that's going to be helpful, but they represent the same value. Okay. All right. So if I looked at this particular problem, started with A to get to C. So my vertical rise, but this time, which direction am I going? Down. And when we go up or down, down represents what kind of a number? Negative. So we would go 1, 2, 3. -3 over the run to the right is positive 1, 2, I would get -3/2. I did the C, I would go, let's see, down 1, 2, 3, 4, 5, 6. I guess we're going to run positive 1, 2, 3, 4, which simplifies to -3/2. But if I wrote it as an average rate of change, so I have a denominator of 1, what would my numerator become? -1.5. Now, neither one of these examples had either of my axes defined. But we do know that the vertical axis is always the what? The function. So we know this is the function, which means this is the variable, right? So if I came over here, I'm just going to look at this one right here. We know the function is my vertical or my rise, and that represents amount of money in dollars. So I'm going to call it M. And so this is money in dollars. My variable is, I'm going to call it T, which is time in weeks. Now, if I were to create a table based upon this graph, then I know that what goes on top, your variable, which we called it T. So this is T weeks. This would be M money. Okay. So when T is 0, what is M? Yep, you go up here to 30. So at 1 week, how much money do we have? 1 week. 35. Yep, halfway between 30 and 40 is 35. And then 2 weeks would be 40. And then 3 weeks would be 45, and so forth. Okay. All right, so let's think back to how we calculated the average rate of change, and I'm going to do it from 0 to 1 weeks. So we do the change in the function over the change in the variable. So of course, that would give me 35 minus 30 over 1 minus 0. So that average rate of change. And now when I get 5 over 1, we can label our numerator and our denominator. What should I put with 5? Dollars. And what should I put with 1? Week. Okay. Now, that's using the process of average rate of change. I want to show you that that still holds true even if we were looking at rise over run. I'm going to choose this point right here, and I'm going to choose this point right here. Okay. Now, here's where you need to be careful, because when we're going to go up, if you just go 1, 2 over 1, 2, that's deceptive because I'm going up 1, 2, but what does that represent in relationship to my function? $10. And so that puts me here, and then this would be 1 week, 2 weeks. So 2 weeks. So we also get $5 over 1 week. Okay. So I just want to kind of look at that because that is the premise of what we're going to get started with in chapter 3. And so I just wanted to review some of that stuff with you if you haven't seen it in a while. All right. So in this chapter, we're going to look at slope. We just talked about slope is rise over run. How that relates to rates of change, which we just talked about, the average rate of change. How that also relates to, this is linear equations. Okay, linear equations will always graph what type of a picture? A line. And this goes back to what Savannah mentioned first. The linear equation that we're most familiar with is y equals mx plus b, m being your slope. Then I don't know if you remember from the last unit, how do we know it's linear? Because the largest exponent is 1. We don't have like x cubed, okay? All right, linear data. So linear data is similar to when we look at a table. We know we have an X value and a Y value, and that would give us an ordered pair. So like if we went back to this, a variable is always first. This would be the ordered pair 0, 30, which would be 0, 30, this point right here. This next one would give you the ordered pair 1, 35. Which we would go over 1 up 35, and it would be that point. So that's what it's talking about when it says linear data. And then something that is going to be probably new to you, that as we go in the unit we'll get into, is linear regression. So we're going to be looking at what are called scatter plots. And line of best fit. Okay, so when we have a straight line, every point on this line or every ordered pair would be directly on this line. Okay, so that would give us, it has a linear or a linear graph, but sometimes you may be graphing and you look at a scatter plot and it maybe looks like this. So obviously I can tell that all the ordered pairs are not on the same line, right? But there would be what we call a line of best fit because they are all going in the same direction. Some of them would fall directly on the line, but not all of them. But this orange line would be what we call the line of best fit. And that is something eventually that we'll be looking for and learning how to do in our calculator. Okay, all right, so 3.1 is just gonna get us started, which we've already talked about. Now, if I put this to make a square in the corner, what am I saying about this triangle? Is anybody? It's a right triangle, okay? So one of the things that we're gonna be doing eventually is we want to use the relationship of a right triangle, which is going to help us find a slope. And then that will then help us proceed with the problem. Okay, so when I look at this in relationship to the slope, then I know my slope is, we just talked about rise over run. So rise is your vertical rise. So that's what goes up or down. So this would be our vertical rise. And left to right would give us our horizontal run. Now, if I know both of those values, then I can find the steepness of my slope. Now, I don't have number values, but you can tell me something about this slope. What can you tell me about this slope? It's a negative slope. This would give us a negative slope because it's going down. All right, if I were to draw another triangle, even though it's going the other direction, here is your vertical rise. Here is your horizontal run. Those two values would allow me to find this slope. Now, even though I don't know that numerical value, I can say that the slope is positive. So we know this is a positive slope. Okay. All right. So the first type of problems you're going to be given, and most likely you will see in WebAssign, it's going to give you some information and you're going to have to find an unknown. Okay. So as I read this, it says a line has a vertical rise of 4. So they're telling us the rise is equal to 4. So if I had a picture, they're telling me this rise is 4. I don't know, 4 inches, 4 feet, it's just 4. And they're telling me that the slope is -2, and it wants us to find the run. All right, so here's how we're going to approach that. We're going to use the rise over run slope formula. And when I look at this, I said, okay, M, they gave that to me. So in place of the M, I'm going to put -2. And then I look and they gave me the rise. So that goes in the numerator. And I am looking for the run. I'm going to call it N. So then what I've got to do is solve this equation for N. And a lot of times when you look at this, you go, oh, crud, the N's in the denominator. What do I do? What do I do? What do I do? Well, I'm going to show you it's not that difficult and the easiest way to do this. How can I rewrite the number -2 as a fraction? Meaning I want a numerator and a denominator, but I have not changed its value. I can put it over 1. Now, when we have two rates or two fractions across from each other of the equal sign, the easiest way to do this is to do cross multiplication or cross products. So what we're going to do is we're going to take -2 times n, which is -2n, equals, don't drop that equal sign. So many students get lazy and drop the equal. 1 times 4 is 4. And then to undo this multiplication, we're going to divide. And we get n equals -2. what have I just found here? The horizontal run. So we found the run to be equal to -2. So if we had a line, we're saying we're gonna rise 1, 2, 3, 4 and run -2. So it would, whoops, my line got crooked. It would look something like this. And the slope is negative and that goes downward. That's not a very straight line, Schanberg, but you get the drift. Okay, next one. Now we're given a run of 6 and a slope of 2. It wants us to find the rise. All right, so we're going to do the same approach. So my slope is 2. I'm going to go ahead and write that as 2/1. That is equal to rise. That's what we're looking for. So I'm going to call that N over run, which is 6. And so we're going to apply cross multiplication. So 2 times 6 is 12. 1 times N is just N. I'm done. What did we just find? The the vertical rise. So, gosh, I don't know if I can get 12 in. If I started here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I'm running +6. 1, 2, 3, 4, 5, 6. So it would look, oh, that's a better line. Something like that. And that makes sense. My slope is positive. It's going upward. Okay. Now, as we get into the application problems, then you're going to either, I like to draw a picture, so I'm going to draw a picture. No, I'm not good at it, but I do the best I can. Or a picture will be given. And typically what we're looking for is a slope relationship. So we're going to be looking for those right triangles. Okay. Just go ahead and put it up for me, please. All right, so let's see what we've got here. A ladder leans against a wall so that its slope is 1.4 feet over 1 foot. Okay, so here's what I'm going to draw. All right, so here's my wall. Here's the ground, which that intersects at a right triangle, no, right angle, which is 90 degrees. And then what we've got is we have a ladder that is leaning up against that. This is my ladder. Okay. All right. They give me the slope. Slope equals 1.40 feet per 1 foot. That's what feet per feet means. Okay, so I'm going to write it as a unit rate. All right, the top of the ladder, okay, here's the top of the ladder, is 7 vertical up and down feet above the ground. Okay, so what they're telling me here is this is 7 feet. So in relationship to my triangle, what did they give us? The rise. What is the approximate horizontal distance from the base of the ladder to the wall? So here's what it's asking me to find. So of course they're asking us to find the run. So we're going to apply what we did before. Slope is 1.40 over 1 equals rise was given. I'm looking for run. And then we're going to cross multiply. So 1.40 times n is just 1.4 n or 1.40 n. 1 times 7 is 7. To undo that multiplication, we're going to divide. So n equals, what'd you find that to be? Okay, and not just 5, but 5 feet. So we have found that the horizontal run is 5 feet, which is what it asks for. Okay. Okay. In this next one, you want to be sure something's going to occur in this one that if you don't pay attention to how I tell you to handle it, you're going to get it wrong every single time, most likely. Okay. So as you'll see as we do these problems, many problems are going to deal with the pitch of the roof line, because that represents a slope, right? Okay, so I am at the center of a circus tent. So here I am, where the height H, here's H, so from here to here is 27 feet. So they're telling me this is 27 feet. I am facing due west, which I take to be in the positive direction. The slope of the tent line is, so this slope line right here is negative 0.7 feet per 1 foot. How far from the center of the tent, that's right here, does the roof meet the ground? Okay, so just looking at our picture and labeling everything, we were given the slope, and what else were we given? The rise. And it is asking us to find the run. Okay? All right, so if we approach this just like we did on the prior example, I'm going to write my slope equals to rise over, and I'm looking for the run. Now, here's where you need to be careful, because if I went ahead and calculated this, I'm going to get negative something feet. Can feet be negative? No. Okay, so the slope of this is negative 0.7. What is the slope of this? Positive 0.7. Okay, so we know the slope doesn't matter which direction, it's the same slope. So when you calculate these, because you cannot calculate a negative distance, you will always use the positive slope. So we're actually going to use the positive slope so we get a correct distance calculation. All right, so I'm going to cross multiply. So I get 0.7 times n is 0.7 n, 1 times 27 is 27. Undo that multiplication by dividing. Now, I doubt this comes out to a whole number. Give me 1 decimal point, normal rounding rules. Do I have that confirmed? She got 38.6. Yes. Yes. Okay. And what are we talking about here? Feet. So the run is 38.6 feet. Now, we know in WebAssign, it's going to say the word feet there for you, and you only have to put in the number. I don't love that because it gets in a bad habit of not paying attention to that, because on the test, you have to put that. So I'm going to go ahead and write, we found the run to be 38.6 feet. Okay. All right. Now, we've got a whole lot going on in this one. So you have to be intentional when you read and get a visual of what's going on. And again, dealing with slopes, ultimately, we're probably going to have to find some right triangles that are going to be helpful to us. Okay. All right. So trusses are shown in the figure below are to be constructed to support the roof of the building. Okay, we didn't know what a truss was. Talks about supporting the roof. So what is supporting this would be these two right here. No, take that back. Yes. Yes, that's correct. These are your trusses. Okay. Then it goes on to say that the truss is to have a 16-foot horizontal base or a joist that spans from one wall to the opposite wall. Okay, so right there, this 16-foot is talking about this piece right here. So that is 16 feet, and that is talking about this right here. Now, I don't know if I'll need it, but could you tell me how far it is from here to here? 16. It's 16 feet as well. So sometimes you have to look like that because you're going, oh, I need this and I don't have it. Well, yeah, you actually do. It's right here. Okay. All right. The vertical center strut is 4 feet long. That's talking about this right here. Okay. All right, so before we get to answering any questions, the first thing that I want to do is see if I can find the slope. I want to look for the slope of the roof. So I want to see if I can figure out what the slope of the roof line is. Okay, so in order to do this, we need to find a right triangle that gives me the values of rise and run that would allow me to then do rise over run and find that calculation. So does anybody see it? Okay, I have an 8. What'd you say? What'd you go with what? All right, not that 3 feet. I want rise. Tell me how you got 8. I'll go with 8. Okay, 8 feet in the vertical. Okay, look here. I think if I'm understanding correctly, he's seeing this right triangle right here. It includes the roof line. I'm going to write it over here. The vertical is 4 feet. So there's my rise. Now, I agree with the 8. Where and how did he get 8? Half of 16. So from here to here is 16, and this is half of it. So 16 divided by 2, we know this to be 8 feet. So that allows me to find my slope, which is rise. Which number is my rise? 4. And my run? 8. Now, we know this to be 1/2, but I don't even want it as 1/2. I need to write this to where we have 1 in the denominator. So what would my numerator be? What's 4 divided by 8 in decimal form? 0.5. So we get 0.5 feet over 1 foot. Okay. All right. So this is as far as I got in my 9:30. So even though we could go a little further, I'm going to go ahead and stop here so my classes aren't on different. Okay. So concerning your assignment, we have not concluded this.